for this last lab of the year, we're going to test the thermodynamic properties for the dissolution of potassium nitrate. In this lab, we need a hot plate, a hot water bath, a graduated cylinder, a stir bar, potassium nitrate, a temperature probe, and I chose to use a burette to accurately add water, so to make this a little bit easier. This is the last lab we'll be doing this year. So at this point, I'm going to weigh out 20 grams of potassium permanganate. I'm at 20 grams of our potassium nitrate. Pour it into our graduated cylinder. The exact mass is more important than getting exactly 20. Now give me a minute. This will take a few seconds as I have to add gram after gram after gram. That's already 10, almost 11 grams. There's 14, almost 15. There's 18, just a little bit more. Okay, that's good enough. Let's close this up. Get a good one. 20.240. Now I'm going to pour this into the graduated cylinder. After pouring it all in, there's about 0.26, maybe 0.25 grams remaining. So let's subtract that for our final mass to figure out how much did we actually add. Well, I'm going to do things a little differently from the instructions. Now, normally I'd be adding 15 mils as accurately as possible. Well, what's the most accurate way to add 15 mils is by burette, rather than using graduated cylinders. So the current reading is 0.0. I'm going to add up to 15, best I can. But I will know exactly how much I've added. And I'll show you a picture, but it is 15 mils exactly. Now that we've added our water, we need to know how big the water is so we can measure the stir bar. So I'm going to take a picture of the not quite solution yet, and we're going to add the stir bar. After recording the volume in the flask, I'm now going to add the stir bar and determine what the new volume is, so that when I add more volume, I should hypothetically know how much I have. But then again, using the burette, I probably don't need this. But we'll have it in there. At this point, I'm setting up my apparatus so that I can stir and dissolve this. This is a hot plate. I'm going to have the graduated cylinder in here. I need to set this up. As it starts to dissolve, it will start stirring a little bit better. But now I'm allowing this to set this maybe at 100 RPM. We'll see how this goes. But I need to set this so that this is heating up, and eventually my potassium nitrate will fully dissolve. Once it is fully dissolved, I'm going to take it out, allow it to keep stirring, and find out the temperature at which it crystallizes. So now it becomes the waiting game. So I forgot to record this, but the volume of our solution, now that it's fully dissolved, is 26 milliliters. Okay, you can't quite tell by, but this has been a long time later. It's finally all dissolved. I have it stirring at 400 RPM, and I'm going to keep it stirring at 400 RPM. I'm going to stick this probe in there and raise this up and bring it down to keep stirring. So, and then we're going to see how long it till it crystallizes. So pull this up, down, clamp, temp probe for when this. Oh wow, this is already starting to crystallize the second I put this probe in here. So actually I'm gonna leave the probe in here. And I'm gonna reheat this and try again because that was unsatisfactory. Let's try again. Let's try again. Raising this up. Down. Submerged so that I can get a temperature reading for when this starts to crystallize. So as this cools down, it will start to crystallize. And at that point, that's when we can say that's when we take our temperature reading. The problem last time was putting a cold probe into a hot solution is going to rapidly change the temperature and cause our crystallization. So, still going at 68, dropping down. Down to 67. I'm starting to see crystals appear at maybe 66.3, maybe 66.4. Keep going. Now to the 26 milliliters, I added exactly 5.0 milliliters via the burette. So the total volume is now 31 milliliters for the solution. For the sake of sanity, I'm going to try to just show you right when it starts to crystallize rather than play the waiting game. Otherwise, we'd be looking at another half an hour of lab for you guys to watch through. Still waiting. Still waiting. .5 and still no rapid crystallization. Still waiting. Starting to see some now. 53.1. 53.1. Yeah, it's really starting to crystallize now. Yeah. There we go. There we go. 53.1 would be that good point. Now it's starting to rapidly crystallize. Yeah, 53.1. Bam. It's large amounts of crystals at this point. At this point, I've added another 5.05 mils by burette, and so the total volume should be something like what? I think 36.05, something close to that. Ready to do volume number 3. Still working on trial 3. Trial 3. Temperature for the crystallization trial 3, we're at 44.2. Still waiting. Starting to see sun. 44.1. 44.1, they're all coming. Oh yeah, there we go. It's now becoming very cloudy. 44.1 is where our crystallization occurs. I've now added 4.95 mils to make it up to an even 41. Even 41.00. Trial number 4. That sweet crystallization. We're at 33.8. Nothing really yet. And drop. Slowly drop. .6. Oh, there it goes. The dust storm. 33.6. Exactly. I've added another 5 mils exactly to bring up the total to 46. So hopefully, the way this is going, I probably won't be able to do more than one more trial if I can even get this trial to work. So we'll see. Trial 5. Waiting for that crystallization. 31 degrees. 31.9, 31. What? 31.8? Well, let's say 31.7. Okay, we'll go ahead and stop it at this point after trial 5. As it is, trial 5 kind of throws off our curve a little bit, but we'll work with the data we have. So you need to calculate the molarity of your solution at each point by finding the total volume of solution. So we need to find the total volume of solution after we've dissolved all of it, and then we've added essentially 5 mils each time. Then once we have the molarity of potassium nitrate, you can find the KSB of potassium nitrate based on the molarity at that temperature. So because we form potassium and nitrate, so you essentially square the molarity. From there, we need to turn our temperature of crystallization to Kelvin. And then you'll graph the natural log of the KSP versus 1 over the temperature in Kelvin. And that's going to be our first graph that we are going to make. Once you have your graph, you can do all your calculations you need. You can calculate your delta G from your negative RT ln KSB for each trial. We can use our graph to determine delta H because the slope is equal to negative delta H over R. And then finally, using our delta H and our delta G, we can calculate our S for each trial, our entropy, and compare it to what is the S in our graph. Our graph, S is equal to the y-intercept over R. So compare those two values. That is the final calculation you need to do.